All right, my name is Chris Holdgraf. I'm one of the leaders on the Jupyter Book project, and I'm also the executive director of the International Interactive Computing Collaboration, or 2I2C. And today I want to give just a really quick introduction and an overview of the major functionality of Jupyter Book, which is an open source tool for building beautiful publication quality documents from computational material. And this is done in partnership with the EarthCube project out of NSF under the Jupyter Meets the Earth grant with Fernando Perez. So before I go any further, I just really quickly want to say thanks to the broader Executable Books community for all of the work that they've done across all of these different projects. I'm the one that's going to be talking about this stuff, but really I've done a small minority of the work compared to everybody else who's put in time and development and thinking and fundraising, and I really appreciate everybody else in the community for all of the hard work that they've done. And if you want to learn a bit more about that Executable Books community, check out the URL right there. Okay, so first off, let's cover a little bit of Jupyter Book basics. So what is Jupyter Book? The simplest way to describe Jupyter Book is that it just allows you to take a collection of computational content, so notebooks or Markdown files or a variety of different kinds of text files, and then it allows you to package and share those files as an enriched, explorable book or article or other computational narrative. So as an example here, we have a bunch of Jupyter notebooks on the left. You can use Jupyter Book to distribute them as a book with a table of contents here, an in-page table of contents, and you keep a lot of that interactive, rich web experience that you would expect in a Jupyter notebook. You can also output different kinds of output formats. So this, for example, is a PDF that goes via LaTeX. So you can use Jupyter Book to create a variety of different kinds of outputs depending on your use case. Jupyter Book is relatively new and we're still developing it and sort of figuring out the major pieces that are going to go into Jupyter Book. But I wanted to share a few of the goals of the project to help understand how we're trying to move things forward. Our goal is to display notebook or other computational content in a more traditional, beautiful, accessible form. So for example, just sharing a Jupyter notebook as a collection of HTML files that you can host in any kind of web hosting service. We want to focus features around authoring and reading and sort of scholarly workflows within the Jupyter community. So rather than something that's more data science focused, thinking more about the kinds of things you would need for proper technical documentation and authoring. We want to build lots of connections and modularity between Jupyter Book and various services out there for interactive computation and interactive services. And we want to make this as easy as possible for you to deploy and share with other kinds of people. And then just again to sort of highlight one of the major pieces here, we want Jupyter Book to be as modular and composable as possible so that you can use pieces of it if you wish, and you can choose not to use some pieces and you can use certain ones on their own. If you want to see a good example of a Jupyter Book and also learn more about Jupyter Book in general, I recommend going to jupyterbook.org. That's the major documentation for Jupyter Book. It has a getting started tutorial and it has topic guides for doing a bunch of more specific things in the Jupyter Book ecosystem. So what happens when you build a book with Jupyter Book? So let's say you start off with some raw content files. Again, these might be IPyNB files, they might be Markdown files, they might be text-based versions of Jupyter notebooks, and you want to build these into a Jupyter Book. The first thing that happens is that Jupyter Book finds any of your content files that are meant to be notebooks. It executes all of the cells in those files, and then it stores and caches the outputs from running that code. And as a result, you'll be able to then take those outputs and store them for future builds of your Jupyter Book. You don't have to rebuild them every single time that the book is built. So the result of this step is that you now have your content files and your computational notebooks, as well as outputs that are the result of running the code. What we can then do is build an enriched document model of all of these different pages. And this is where you can insert things like citations and cross-references between pages. You can include metadata that is relevant specific to publishing, such as bibliographies. You basically take a bunch of independent pages and you turn them into an interconnected book or an interconnected collection of documents and articles. And then finally, once you have this interconnected web of documents, you can choose a variety of different outputs, such as PDF, HTML, a variety of different kinds of PDF outputs. So you have an enriched document model, and then you just need instructions for how to turn that model into one of many different kinds of outputs. And this is valuable because that document model in the middle is abstract. It's not dependent on any one particular kind of output, and that provides you that flexibility that is really important in the Jupyter Book ecosystem. So as I mentioned before, an important piece of this is that you don't have to execute your notebooks every single time that you build. What Jupyter Book will do is cache those outputs, and in subsequent builds, it will check the contents of each code cell to understand whether they have changed or not, or to understand whether contents in a different cell on the same page have changed or not. If they had, then Jupyter Book will rerun those code cells and then update the cached outputs before it builds the book itself. But if they haven't been changed, Jupyter Book will just take a pre-existing set of outputs and insert it so that you don't have to wait for that build time yourself. So what does this process look like when you actually build a Jupyter Book? Well, there are basically three things that you need. One, you need a collection of source files. Those are those Markdown and IPyNB files, notebooks, things like that. Two, you need to create a table of contents, and this defines the structure of your book. And three, you need to run a command line Jupyter Book build, and then your book will be built. So here on the right, I'm showing an example of some content files. This is the Jupyter Book documentation. As you can see in this introduction page, it's just a collection of Markdown text. This is the table of contents for the book, and this is a YAML file that just describes the different sections and files that map onto sections. And now I just call Jupyter Book build, and I point it to the current directory that I'm in. What you're seeing is actually the output of another tool called Sphinx. Sphinx is a document generation tool in the Python ecosystem, and Jupyter Book uses it under the hood in order to build all of this documentation. Now, once that Jupyter Book build is finished, I have a collection of HTML files on the left, and I'll just open up a really quick preview so you can see what this looks like. So this is that same intro.md file that I was looking at before, but now you can see all of those content blocks are enriched. We have some nice admonitions. We have a much more modern web-based looking output, and that's the kind of thing that you could share with your colleagues and with your friends. So that's the goal of Jupyter Book, is to facilitate that basic workflow. Okay, so let's dig in a little bit into how you author content, or the options available to author content, and talk a little bit about some of the features that are at your disposal as well. So the most interesting thing to note about Jupyter Book is that it supports a new flavor of Markdown that's called markedly structured text, or MIST. MIST is a rich and extensible flavor of Markdown that's designed for technical documentation and publishing. So what does that really mean? So MIST is a superset of Markdown, which means that it's a superset of Common Mark Markdown, which means that any Common Mark document is also a MIST compliance document. Common Mark is a really common, it's arguably the only Markdown standard that exists, and so a lot of different documents and services support Common Mark Markdown. But in addition to the base Common Mark syntax, MIST provides several new kinds of syntax for different kinds of workflows that are particularly relevant for scholarly communication and publishing, that kind of thing. And probably most interesting, it provides two extension points in syntax. Those are called rules and directives. Those allow you to extend MIST's functionality on your own. And I'll dig into what that means in a little bit. MIST comes with its own Python parser as well as its own JavaScript parser. So it's language agnostic, and you can use it in a variety of different situations. And on the Python side in particular, MIST comes with a parser for Sphinx. So for anyone who's familiar with the Sphinx documentation ecosystem, you can use MIST to parse Markdown files in Sphinx. And you basically get all of the same features that Sphinx offers for restructured text, which is another markup language. You can get all of those features using MIST Markdown as well. So there are a couple of different things that you can do with MIST that allow you to create more of these sort of publication-friendly outputs. One of them is semantic code blocks. And at the very top, I'm showing you an example of a directive, which is, as I mentioned before, an extension point that MIST has for how you can extend the base Markdown language into new kinds of structures and outputs. Directives are kind of like functions, although they're for Markdown instead of a computational language like Python or R. So on the top here, I'm showing you an example of a directive. This is an admonition directive. The title of the directive always goes in between those little curly brackets. The directive has a single argument, which is, here's your admonition up there at the top. And then inside of the directive, we have content for that directive. Here's the admonition content. When Jupyter Book builds this book, it will find this directive and it renders it as such. Now, the way in which this argument here, this title here, and this content here maps on to a particular kind of output, that's something that extension authors have control over, and they can define the kinds of rules that they would like to use in this case. Directives can also have key value arguments as well. And so on the bottom, I'm showing you an example of that. So here we have admonition, we're choosing a new title, and I'm putting in colons here this class argument. What this will do in the case of admonitions is it adds a CSS class called tip to the output admonition box, and that changes the styling of the admonition. So using similar kinds of syntax, you can also do things like add citations and cross-references across pages of your book. Here I'm showing you an example of a role, and a role is another extension point in the MyST Markdown ecosystem. Roles are basically inline versions of directives. So while a directive spans multiple lines and it exists as a block, a role can be added inline with your text. So, sandwiched in between two different words or two different sentences, that kind of thing. So in this case, I'm showing a role called cite, and this is how you can add a bibtext citation inside of your book. When you render your book, when you build your book, it will result in a reference like this. And later on in your book, you can use a bibliography directive to generate a bibliography like so. And this allows you to insert citations into different sections of your book and then provide links that automatically jump to other areas of the book for bibliographies and for more context around those citations. Using a similar syntax, you can also do things like controlling figures and captions and different kinds of aspects of the look and feel of any kind of images that you want to display. So here I'm showing an example of a figure directive. So there's the directive title, it's just called figure. The argument of that directive points to an image that's local on disk relative to the root of this page. And here I'm providing two different arguments, although using a slightly different syntax than before, to specify the height and the name. This is a unique name for the figure so that I can refer to it later on. If you have a lot of arguments inside of a directive, rather than using the colons sandwiching the argument names, you can also just add these three little dashes at the top and the bottom of your keyword arguments section. And this is just an easy way to delineate where your keyword arguments are from where your directive content is. So when I build my book using this figure directive, here I can see the output. I've capped the height at 150 pixels, so this looks relatively small. And interestingly, I've also added this my figure name, and this allows me to refer to this figure later on with a cross-reference using the reference role. So because Jupyter Book is built on top of computational content and with sort of interactive Jupyter-style material in mind, you can also do a lot of interesting things around outputs and reusing pieces of your computational code. So one new-ish feature that we're still prototyping, and it's kind of in a beta mode right now, is called the glue role and directive. What glue allows you to do is store the outputs of executing a cell to a specific key. And that key can be unique and something that you can refer to in other parts of your book, either later on in the same page or on a different page of your book. If you reference that key, you can do things like inserting those outputs wherever you would like to. So here on the right, I'm showing an example of inserting a bootstrap simulation that was defined on some other page in a different Jupyter Notebook cell. And I'm just taking the output, which is an image, and inserting it in my document. You can also do this inline. So you can do things with a number that was the result of some computation, like a statistic, and you can even insert things like images inline if you wanted to create something like a spark line. And again, as I mentioned, because Jupyter Book is built with computational content in mind, you can also use other tools in the Jupyter ecosystem to facilitate your authoring of content and version control and things like that. As one example here, Jupyter Book comes with built-in Jupytext support. Jupytext is another open source tool that allows you to use two-directional synchronization between traditional IPyNB notebooks and text-based representations of those notebooks. MyST Markdown itself comes with a specific flavor that will represent a Jupyter notebook for you. I'm showing an example of that here on the left. Effectively, what we do is just define a code cell directive in MyST Markdown. And when you build your Jupyter book, it will treat that as a proper Jupyter notebook and execute the content and keep the outputs as well. So this is a way that you can write all of your content in a text-based markup language that makes things like collaboration or diffing with Git much easier, but you can retain the functionality of a Jupyter notebook. You can also insert other kinds of user interface elements that allow for interactivity into your Jupyter book, in particular if you're using a web-based output. And here I'm just showing you two different examples. Using a tab directive, you can insert collections of tabs relatively easily into your book. Here's an example of what it looks like on the left. And using panels and dropdowns, you can create flexible modular user interface components for different parts of your page. You know, if you want to have a dropdown that requires users or readers to click in order to see what's inside, you can use that relatively easily using a directive. Okay, what are some other features that we can use to integrate Jupyter Book with other tools in the Jupyter ecosystem and the broader sort of interactive computing ecosystem? For one, Jupyter Book comes with built-in support for a few different kinds of metadata that might exist inside of a Jupyter notebook. So as many people know, Jupyter notebooks are extremely flexible and they're basically structured data formats. So you have your content cells, you have your code cells, you have your output, and all of this exists in a structured way inside of an IPyNB file. And each of those cells can come with its own set of metadata. The most common one that people use are things called tags, which are just short little strings that you can really quickly attach to every single cell. Jupyter Book knows how to use certain kinds of tags to control the behavior of the output when you're using a Jupyter notebook with Jupyter Book. And just a couple of examples that I'm showing you here, if you use the hide input, hide output, or hide cell tag, then when you build your Jupyter Book, those cells will have their respective elements hidden, and they will allow users to click on things in order to show what's inside. So this can be really useful if you're trying to explain an idea or you're trying to cover some kind of pedagogical content where you don't want people to see the outputs from the very, very beginning. You can also use Jupyter Book to connect to other services that are out there that might be running in the cloud, for example. So tools like Jupyter Book can connect with other services like Jupyter Hub or Binder or the Google Collaboratory. You can do this via configuration at the central book level. And what I'm showing you here is a page that was built with a Jupyter notebook. So that's the Jupyter Book source file is an IPyNB file. And I've used Jupyter Book to automatically insert binder links into each page of the built Jupyter Book. So when I click that link, I'm now taken to a binder instance of that page where as a reader I can explore, run the content on my own, change things on my own, and generally get a more rich interactive experience with the book's page. So a lot of people use these kinds of features, again, from a pedagogical standpoint, if you want to provide people a really easily accessible static web page so that they can learn more easily, but then provide the opportunity for them to interact with the full thing in all of its complexity. You can use these launch buttons and connections with other services in this kind of way. But say you wanted to provide interactivity, but you actually didn't want to require users to move to a completely different page. For this, you can use a relatively new tool. Again, this one is in sort of beta or even alpha prototype mode. A new tool called Thebe. What Thebe allows you to do is connect a static web page with an interactive kernel that lives somewhere in the cloud, such as via a Jupyter Hub or via a Binder Hub. When it connects with that kernel, what Thebe does is it takes all of your static code cells and it turns them into interactive code cells. So here, for example, I'm turning a static code cell, connecting to a Binder kernel, and then rendering that static code cell as an interactive cell where I can start to manipulate it myself. I can change parameters. I can see that interactive input in line with the page. And all of this is done without having to leave the page itself, which is a really great way to blend interactivity in a selective fashion into your book without requiring people to jump around to different websites and that kind of thing. And beyond just the interactive computation use case, there are also a lot of other really great features for interactivity in general around collaboration and authoring and reading. And two examples that I'm showing here are around interactive commenting. Again, Jupyter Book is primarily outputting static web pages, but you can include connections to other interactive, more dynamic services, such as utterances, which I'm showing on the left, or hypothesis, which I'm showing on the right. These are two different ways that you can include commenting style functionality inside of your Jupyter Book. So on the left, utterances allows you to connect your book with a GitHub repository, and then it provides a relatively lightweight JavaScript widget that allows you to embed comments inline on a page that are linked with issues in your GitHub repository. So when someone makes a comment on your page, it just shows up as an issue in that repo. Hypothesis provides a more sophisticated commenting overlay, and it also has its own centralized database and engine for managing all of those comments and annotations. It allows you to do things like highlight certain sections of a page. You can have an identity that you take with you from one page to another. So you might have the same person commenting on hypothesis pages for multiple Jupyter books. This is often used in classroom settings when you want people to provide their own thoughts and input on a page, for example, to facilitate class discussion. And then finally, I think in some sense the most important thing about Jupyter Book is that it is a community-driven tool. So everything that I mentioned thus far are modular, composable, open source components. The executable books community as well as the Jupyter community are both open communities that have many different kinds of stakeholders and many different kinds of developers contributing to them. And they're largely made up of people like those in the EarthCube community or the geosciences community or the broader research and education community. So if you like Jupyter Book, or if you have ideas or opportunities where you think it could be improved, you're more than welcome to join in, provide comments on issues, open issues yourself, make some code contributions if you'd like to. Don't hesitate to reach out and ask any questions if you'd like to know either more about Jupyter Book or if you'd like to know more about how you can contribute and join the broader community. So that's my short little tour around the Jupyter Book ecosystem. I really just touched the surface about a lot of different kinds of things that you can do in Jupyter Book. But what I would recommend is that you just go to the documentation, jupyterbook.org, and follow the Getting Started tutorial, which will take you from beginning to end of building your own relatively simple Jupyter Book. From there, you can dig into the topic guides, which are going to give you more in-depth information about doing more specific things with Jupyter Books. And then I recommend that you connect with the broader community, share the kinds of things that you've created, ask questions, and start to engage and learn a little bit more. So thanks very much for your time, and I look forward to seeing you all on the Jupyter Book comments and issues in the Jupyter forum. Thanks very much.